page 10 of the scheduling notes. This section is about tasks, really about task scheduling. Section 4.1 is task states, and I'm going to show you a diagram that's from the RTOS2 documentation. It's got 4 states, so running is in the middle. You want to space them out a bit because we're going to label the the edges between them. Okay, so I think I'll add the arrows and then I'll switch to another color to label them. Just make sure you're giving yourself enough room for some labels on each arrow. You'll notice that some are single-ended. The one from running to ready is double-ended. Alright, I hope I've done what I said and left myself enough room. So now I'm just going to switch to green here to label these. So when you are creating your application from your main, you need to create at least one thread before you start the scheduler. So when you've created that, but the scheduler is not started, it will be inactive. But then once the scheduler starts, it will switch to the running state. Also, whenever you create a new task, a new thread, it can either go straight to running or it can go to the ready state, either one. It's not possible for it to start out blocked. And if you have a running task and it gets terminated either by exiting or another task terminating it, which you can do, it will go to the terminated state, and the return value can be collected by other threads. Okay, when a running task ends its time slice and there are other tasks of this equal or higher priority ready to run, then it will be preempted. So its context will be saved and another task will be scheduled to run. So that's how you go from running to ready. But also when a task is ready and it becomes its turn to run, it will transition to running. You can go from the ready state to the terminated state not by terminating yourself, but if another thread terminates that thread. Okay, now from running, you get to the block state by waiting. So waiting on something like an event flag or doing an OS delay, stuff like that will cause it to block. You can also wait on timers and various other things. When whatever condition it's waiting for is satisfied, so when the event that it's waiting for occurs, then it will transition back to either the running state if it happens to be the high priority task at that point, or to the ready state. And we have one last edge here to label. So a task can be blocked, waiting for something to happen, and it can be terminated by, I keep saying mixing my tasks and threads, but anyway, it can transition from blocked to terminated. So every time one of these transitions happens, then the scheduler is going to be invoked and it's going to need to decide which task to run next. So the scheduler is run when a task is created, and that occurs with OS thread new. So I'll put the OS calls in green. It also is called when a task terminates, and there's two calls that can make that happen. OS thread exit. So you can call that explicitly, or the main function for your thread, if it returns, then that also terminates it. Or alternatively, another thread can call OS thread terminate if it knows the ID of the thread that it wants to terminate, and the thread ID is returned when you call OS thread new. So I think that you saw in one of the the lab videos yielding. So yielding is saying to the scheduler that you can go ahead and schedule somebody else, but once they've had their turn, or the other threads have had their turns, then come back and run this thread again. And so that's OS thread yield. So it's a way of giving up a thread's time slice early. Back in the Windows 3.1 days, so that was, I guess it sort of had a graphical user interface. It was pretty common for a good long while. It didn't have true concurrency. It had cooperative multitasking. So if you had multiple programs that you wanted to cooperate, I think they're programs, not threads, then you would have to yield the processor, and then the other one could run, and you would just take turns doing that. Okay, if a task blocks, then obviously it's not going to run, and something else should run. So OS delay, OS event flags wait are the two that we've seen so far, and as I keep saying, there are other occasions when you may block, which we'll see later. When a thread unblocks, and that's going to be as a result of the action of another thread or of an interrupt service routine. So I don't have a call here, but something like the delay ends, so you specify it to delay for a second and the second's up, or the event flag that the task is waiting on gets set, say by an ISR in our example that we just looked at. And finally finishes the time slice. So if you have multiple tasks of the same priority and they're all ready to run, they'll each get a time slice, and then they'll be suspended until their next time slice.